Hello everyone, so in this video, let us talk about the first 4 problems from the latest AtCoder Beginner Contest 275. So let's start. Let us move on to the first problem. The first problem is find Takahashi. So there are n bridges in the AtCoder village. The height of each village, like each bridge is actually h of I. And you have like every two different bridges in the village have different heights. So every bridge has a different height. You have to just print out the maximum highest bridge in the village. You just have to print the, you can say, the index of that. So what you can see here is that in this example, there are three different, you can say, bridges, and the bridge that is the second one that is having the maximum height. So you just have to print out the index, okay, from one index of the maximum height, you can say. So it's pretty simple. You can just iterate over all of them and just find out the maximum of all of them, or you can use the max element function from C++ as well. Let us move on to the code part. I have stored all these elements inside this array A. Iterator like stored them all of them, and then you can just take the maximum element among all of them. This is the function that returns a pointer towards the maximum element. If you subtract out the initial pointer, you will get the, let's say, index of that, which is your index. Plus 1 will become 1 index. So let's say this function returns a pointer, you can say, towards the element that is the maximum among this whole array. Okay, if you put a star in front of it, it will return the value, it will dereference it. If you subtract out the, let's say, the pointer itself, it's just you can say pointer arithmetics, and thus you will get uh, you can say the index of the element that is holding the maximum element, and just add 1 to it to make it one index. Okay, that's the overall code for the first problem. The second problem is ABC minus DEF. So the problem statement says that you are given these integers ABC and DEF. You have to just find out this value. Okay, so A into B into C minus D into E into F divided by this. So you just have to find out the remainder of this whole expression. But the thing is that all of them are very large, okay, and by 18. So it's very difficult to do like directly just multiply this and like subtract out from this, because this will become very large. Okay, long also cannot hold this value. 10 to 18 it can hold maximum. You cannot hold like this value, and this, like this value is also very large. So what you can do is you have to understand the, let's say, modular arithmetic here, like how you can do arithmetic. Okay, modular arithmetic here. Let us take this as an example. So what you actually understand here is that it is A B into C, okay, minus D into E into F. Let's say just take the whole term as M, mod M. Okay, and you just have to find mod, because remainder of that. So you have to do modular arithmetic here. So you have to first transfer all of this mod to all of them. So it will be A mod M, then again into B mod M, into C mod M. Okay, and then you have to subtract out this term. Okay, and you have to do an whole mod M also. Okay, and then you have to do the same thing here as well. Let's say D mod M into, let's say, E mod M into F mod M whole mod M, and that's it. Then you do a whole mod of this. Okay, you can do that. That will return the perfect answer. But this might also give you some error, because you have, like, what you can see, if you just do mod of 2 multiplication, you have to do a whole mod here as well. Okay, this is whole mod, and you have to do a whole mod here as well. And then whatever answer for this is multiply with this. So this is the overall expression. You have to do multiple mods. Okay, that's the whole thing you have to do. Okay, I've written an expression. I'll show you the code part. So what I've done, take all of them is long. This is M. Then you have to take the input of all of this term. So let's say we have a term, let's say X, which is like A mod M into B mod M whole mod M. Okay, that's what I've done the first term. Then whatever X is there, then X mod M into C mod M, or the whole mod M. This will terms the first A into B into C mod M. Okay, then you have to do the same thing for D. And then because you're doing modular arithmetic in subtraction, okay, then if you have this term, you have to also understand that this term, when you're doing modular, it can get less than this M. So for that, you have to, like, when you are doing, let's say, this minus this, you have to add M also. Okay, so this is a very simple like modular arithmetic. If you have not seen my modular arithmetic video, I'll pin it somewhere, or you can search on my channel so that you can understand more on this. So let's say you have X minus Y mod M. You have to calculate this. So it is X mod M minus Y mod M plus M whole mod M. This is equivalent to this. Okay, you can do that also. So that's what we're gonna do. So we have this term. So this mod m minus this mod m plus m, the whole mod m. Okay, so that's what we have done. This term is xa, so xa, let's say xa minus ya plus m, the whole mod m. Okay, that is the terms, and you just print out the answer. That's the whole things for the second problem as well. Moving on to the third problem. The third problem is that you are given a two-dimensional plane, and the plane has the coordinate, the maximum length of it. It's from multi-line, just a chessboard. Now, in this chessboard, there are different pawns. Okay, now these pawns are placed at different locations on this whole chessboard, and the pawns are denoted by hash. Okay, if it is a dot, then it is just nothing. If it is hash, then there is a pawn there. You just have to find out how many number of squares you can build by the pawns as the vertices of those squares. Okay, now you can see that with some example, I hope you understand this, that you can see that in this example that there are pawns here. Okay, these are hashes, we are pawns. So you can create, as you can see, a square with the vertex 1 1 1 2 2 1 and 2 1, or 2 1 and 2 2. So this is a square. Okay, square. Similarly, like this is a square as well. So this is a square. So you just have to find out how many number of squares you can form, and because the length of this is very small, you can just do in a very brute force only. You can just calculate, let's take 4 pointers, okay, and just try to calculate out for everything. Okay, what you can also do is that because you're looking for square, it becomes very much into, like, you can optimize it also by understanding that like for any square you just require its, let's say, it's two coordinate. Okay, let's say it is x1 y1 and x2 y2. From this you can calculate out this point as well, because it's the equal length. Okay, and this point as well, because this point is having the same x1, and you can say that, okay, this is the same x, but the y has, so, or you can say that the x is changed. Okay, this is x2, sorry, x is changed, x2, but the y is same. Okay, y1, and this is having the same, you can say this is having the same y2 and x2, sorry, x1. Okay, so you can see that you can reduce, if you have these two terms, then you can reduce these two terms as well. Okay, so it means that you have to do like nested for loops of finding out this two. So x1 y1 x2 y2. Okay, you just have to do 4 nested for loops to just calculate out for every possible x1 y1 x2 y2. Then you can calculate out these two terms and just check out that this, all these terms should be hashes out, and just add them. That's it. Pretty much simple for the brute force way, nothing much complicated here as well. Just create out you can say matrix of characters, insert all these characters, then the total number of characters that you have, then just form for x1 y1 x2 y2. Okay, for everything. Then if x1 and x2 are same and y1 and y2 are same, which means that it is a singular point, that's not a square. Okay, every single hash is not considered a square. 4 different hashes are considered square. So for that you just continue and don't think about that. Also, if any one of them, so you have taken now x1 y1 and x2 y2, if any one of them is a dot, just ignore them, because all of them should be hashes out, and then also you continue out. Now from that you will just calculate out the another x2 y2, just subtract out the height, okay, of y2 y1, add it, like you can subtract from x3, or you can add and odd them also, depending upon how you consider that square. And then you just find out the other two coordinates as well. Now you just have to understand that the other coordinate should be inbound, and it should not, like, both of them should be also hash. And just if that the condition is also satisfied, because these are hashes. Okay, if any one of them is dot, you will continue. So if this condition is satisfying, if both of them are hashes, and then consider the two other sides that you have calculated out by taking the first two as points, then both of them should also be hashes. So it means that all of them are hash, and just calculate all of them. But the overall thing is that you have taken to consider like two you can see that you've considered this and this. Okay, but there are multiple iterations in which you consider this or this. Okay, because as you can see, now you are taking any 2 points. Okay, so if you're taking any 2 points of this whole square, then this and this can also be considered, from which you can find out the other two ones. So you can see that I can choose any two and reduce the other two ones. So how many pairs I can choose? If I take this two, I can consider this two. If I change this two, I can consider this two. So it means that there are 4 options. I am always choosing. So if I am always choosing the one, let's say on this half, and you can calculate out this two. If I choose this, let's say this two, then I can reduce these two. So from every two, you can reduce the other two. So in which this, when you're doing this for loop, you are actually counting it 4 times. So you have to, in the end, you have to just divide this by 4 also, because you have double, like 4 times counted everything. So you just print out the answer by dividing it by 4. So in this scenario, I'm not taking x1 and x2 as this. Okay, don't consider this as misunderstanding. I'm not considering x1 and x2 as this. Okay, x1 and x2 are considered as two adjacent dots. Okay, now they can be anything because I'm doing a for loop for every possible condition. Okay, for every x1 and x2, if x1 and x2 are this will consider the opposite two directions here. If x1 and x2 are considered this, okay, then these are considered. So what I actually means is that I have taken every possible 2 points that are adjacent, and then for you calculate out the other two one, and then that is how you can calculate the two one. And but they are like 4 times counted, so they divided by 4. That's the whole thing for the third problem as well. Now the fourth problem. The fourth problem is that you have defined a function for a non-negative integer x that satisfies the condition such that f is a function such that for f of 0 equal to 1 and f of k is equal to k, like f of k divided by 2, you can say rounded down, and f of k divided by 3 rounded down. Now for any positive k. Now you just find out the answer for f of n. Now n is pretty large. I thought that it is pretty large, but what you understand from here is that a particular value of f of k depends upon previous or smaller value of f of k. That is just a dynamic programming problem because every value depends upon its previous problem. So you have to like divide it on. It's a recursive problem, but I can do dp on that. So which is like dp. But I thought that it is a very large constraint. But what you can say is that it is also doing exponential. Okay, here. But like exponential dividing out, so like it depends upon very smaller values as well. So let's say if I want to find out for any larger value as well, it will exponentially decrease those values. So it's very simple now. So what you can say is that instead of making a dp table because it's very large and I do not know which value it depends upon, you can just use a map here. So what you can do is that you can just use a map, and this is the recursive function you have, and just you can just do dp on that and just print out the value for f of n. Pretty much simple. So what you can just do for this problem is, let's just do one of the code part. What we have done is that we have created a map. We have to find out the value for n. So let's take the input of n, initialize the dp of 0 equal to 1, which is given to you, the recursive function, then call this f of n with n. This n is just a very simple recursive function. If this particular value exists in a dp, just return that value, or else dp of x equal to this value divided by 2. Just call this function again recursively for this, and this is just this has adding memorization to it, and this dp table is used to do the memorization, and this is the recursive function. That's it. Not that much difficult to understand from here. That's the whole problem for the fourth problem as well. I hope you understand the logical good part for all the 4 problems. If you still haven't out, you can mention in the comment box for this particular video. I will see you in the next one. Thank you, coding, and bye.